numbers are really big, some numbers are really small. I wish there was a way to easily express them all. Hey, I found there's an easy way to show extreme scientifically. Scientific notation does it easily. And now I love science more than I ever did before, can't you see? Express your number so that it's more than 1, but less than 10. Take that number and multiply it by 10 to the proper exponent. 300 in scientific notation is 3 times 10 to the power of 2. 10 to the power of 2 is 100 times 3, that's 300, so there's your proof. Scientific notation uses exponents with the base of 10, so you don't have to write out so many zeros again and again and again. Take a number like 0.0023, plug it into a times 10 raised to the power of b, where a equals 2.3 and b is negative 3. You get 2.3 times 10 raised to the power of negative 3. Express your number so that it's more than 1, but less than 10. Take that number and multiply it by 10 to the proper exponent. 0.03 in scientific notation is 3 times 10 to the negative 2. 10 to the negative 2 is 0.01 times 3, that's 0.03, so yeah, there's your proof. Express your number so that it's more than 1, but less than 10. Take that number and multiply it by 10 to the proper exponent. When you use scientific notation, you become a real hero. It's 5.2, it's not a trick, it's 5.2 times 10 to the power of 0.
Hello, grade 7 students. It's another week, it's another video discussion. So, as you can notice, I started this video with a song that is entitled Scientific Notation. So, our topic for this week or for this video is all about scientific notation. Scientific notation is used when dealing with very large or very small numbers. It is also considered as a more convenient way of writing small or large numbers. So this is the standard form of scientific notation. We have c times 10 raised to the power of n, where c is a number less than 10 but greater than or equal to 1. So kinahanglan ko no nga ang c dili siya moabot og 10 or gamay sa 10, pero dako or equal ni 1. Pasabot gikan ni 1 hangtod ni 9 ra dapat ang naa sa c. Then times 10, 10 is kuha na siya constant. 10 jud na kanunay base of 10. Then kanang exponent niya nga n as ibabaw sa 10. Mounay or n is an integer. Now mounay magdetermine og kapila nimo gi-move ang decimal point. Nya way back our discussion about real numbers, diba integers can be positive and negative. So later on mahibaw-an ninyo og kanus-a siya mga negative, kanus-a pud siya mga positive exponent. Okay, for the steps to write a number in scientific notation, the first step is to move the decimal place until you have a number less than 10 but greater than or equal to 1. So, inyong i-move ang decimal point ko, no? Inyong i-move ang decimal point hangtod mo abot na mo satisfy na mo sa condition ganiha sa letter C. Diba? C kay dapat ang C ko no, ang mabutang sa C kay numbers from 1 to 9. Nga na ra. So, to illustrate further, I have here example para masabtan gyud og giunsa pag-move unya. Let us say we have this number 18,500,000, and we are going to convert this one into scientific notation. So, as our first step, di ba, kay whole number man na, ang decimal point na sa kinalasan. So, ato na siyang i-move. Ibalhin ang decimal point hangtod nga moabot siya, mo satisfy siya sa C or condition sa C nga ang C kay gikan ni 1 hangtod ni 9 ana ra siya nga range. So, ato na siyang i-move. So, hangtod moabot ta ani nga point. So, nganong diri raman tataman? If mo stop ta ni 5, in between ni 8 ug 5, may mo siyang 18.5, di siya mo satisfy. So, muna mo dito ta in between ni 1 ug 8, which is 1.85. So, kana na siya. Mawa na tong 0. Next step is to count the number of times you have moved the decimal point. So, ihapon kung kapila na to i-move tong decimal point kay ang kinaunhan di bang buhaton kay atong i-move tong decimal point hangtod mo satisfy tong unsay condition sa C. Now, for the next, mana matag move. Ipon, simply ipon ra kung kapila gi-move ang decimal point. Going back with our example, a while ago, we have 18,500,000. So 1.85 times 10 raised to 7. So why 7? Because we moved the decimal point 7 times. Now, is integer or is exponent 7 our final answer? So, let us try to examine. So, ganiha akong ingon nga, ang integer, pwede siya positive o negative. So, in scientific notation, kaning exponent pod nga n, pwede siya nga positive o negative. So, unsaon man nato pagkahibaw kung ang exponent positive or kung ang exponent kay negative. So, ingani ra siya ka-simple. So, take note of this. So from standard form to scientific notation, if the movement of the decimal point is to the left, the exponent is positive. While if the movement of the decimal point is to the right, the exponent is negative. So for our example, we will apply the movement to the left kato nga scenario or kato nga situation. Since sa left man nato gi-move, ang atong decimal point, our exponent should be positive. So therefore, our final answer is 1.85 times 10 raised to 7. Okay, so what if we are asked to write scientific notation to standard form? So ganiha, nga itong naibawaan is from standard form to scientific notation. Karon binali na pod from scientific notation to standard form. So unsaon man na siya? Okay, steps to write scientific notation to standard form. So check the exponent whether it is positive or negative to determine the movement of the decimal point. So ang ato rang tan-awon is ang exponent niya. Ang exponent sa scientific notation kung positive ba siya or negative. Now, so unsa man if nahuman na nato, check ang exponent. So if the exponent is positive, we have to move the decimal point to the right. While if the exponent is negative, we have to move the decimal point to the left. So after moving, do not forget to add zeros to fill the empty gaps. Okay, so for our example, we have 1.5 times 10 raised to 4. So first thing nga atong buhaton is to check the exponent. Now, our exponent for our first example is positive. So positive 4. Now we are going to move the decimal point 4 places to the right since the exponent is positive. And then after moving the decimal point, we are going to add in zeros to fill the empty gaps. So from 1.5 times 10 raised to 4, our standard form now is 15,000. Next example we have 5.8 times 10 raised to negative 4. So this time the exponent is negative. So if the exponent is negative, we are going to move the decimal point to the left. So in here, we are going to move the decimal point 4 places to the left, and then we're going to add in zeros to fill the empty gaps. So from 5.8 times 10 raised to negative 4, the standard form now is 0.0005 and 8.